Welcome to part 2 of our video all about prime numbers, and we're going to look at prime factorisation as well today. So let's refresh from last lesson. A prime number is a number with just two factors, one in itself. So some little questions here to warm your brain up. Pause the video and have a go. So is 5 a prime number? Yes it is, because we can only have 1 times 5. So it's only got itself and 1 as a factor. The next one, is 12 a prime number? No, because we can do 1 times 12, we can do 2 times 6, and 3 times 4, so it's got quite a few factors there. Is 13 a prime number? Yep, you can only do 1 times 13. Is 1 a prime number? No, because you can only do 1 times 1, meaning that 1 only has one factor, and to be a prime number it needs two factors. Are all prime numbers odd numbers? No, because our first prime number is 2. Okay, we've got 10 questions here. Again, warming our brain up, so pause the video and then we'll go through the answers. Okay, so write down the factors of 12. So we've got 1 times 12, 2 times 6, 3 times 4, and then obviously we can do 4 times 3, but we've already got it here. So our factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 30, so we can do 1 times 30, we can do 2 times 15, 3 times 10, we can't times anything by 4, that won't get us 30. We can do 5 times 6, and then we're back again to 6 times 5. So 1, 2, 3, 5, 6, 10, 15, and 30. The first 5 multiples of 6, remember that a multiple is times tables. So 6, 12, 18, 24, and 30. The first 5 multiples of 11, 11, 22, 33, 44, and 55. The first 5 prime numbers are 2, 3, 5, 7, and 11. The fourth square number, so a square number is back what we did a few weeks ago, which is, for example, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So our fourth square number is 16. A square number is just something times itself. Which of the following is a factor of 48? So we've got 1 times 48. We can do 2 times 24. Can we times anything by 3? We can do 3 times 16. Can we times anything by 4? We can. We can do 4 times 12. Can't do 5. Okay, we're on 6. Can we do 6 times something to get us 48? We can. We can do 6 times 13. We can't do 7. We can't do 8. We can't do 9. We're just double checking. So 6 is our answer. Is 3 a multiple, factor, or square of 9? Well, a square of 9 would be 9 times 9, which is 81. A square root would be correct if that was an answer, because the square root of 9 is 3 times 3. Is it a multiple? Well, a multiple is your times table, so 9, 18, 27, so it's not a multiple. So let's double check if it's a factor. We've got 1 times 9. We can't do 2. We can do 3 times 3, so it's a factor. Explain why 1 is not a prime number. It's not a prime number because to be a prime number you need to have 2 factors, and those 2 factors have to be 1 and itself. And obviously in 1 you can only do 1 times 1, so there's only one factor. And our last question, 1, 4, 9, 16, 25 are the first of what type of number? They are square numbers, which is 1 times 1, 2 times 2, 3 times 3, and so on and so forth. Okay, so if you can't remember the first 10 prime numbers, then I would write down what's in this bubble now, because it's really important that you know at least the first 10, because it's going to help to make your life a lot easier. Okay, so when you have a question asking to write a number as a product of its prime factors, it's actually really easy. So if we take the number 30, let's split that up into 3 times 10. And because 3 is a prime number, we're going to circle it. That's a really important step to remember. So let's circle the 3. We now need to split the 10 up, so let's do 2 times 5. And both 2 and 5 are also prime numbers. So 30 as a product of its prime factors is 2 times 3 times 5. So now we're going to write 24 as a product of its prime factors. So let's split 24 into 2 and 12. And 2 is a prime number, so we need to circle it. Now we can break the 12 into 2 times 6. And again, circle the 2 because it's a prime number. And now we can break the 6 down into 2 times 3. And 2 and 3 are both prime numbers. So 24 as a product of its prime factors is 2 times 2 times 2 times 3, or 2 cubed times 3. Now it's important to note that it doesn't matter how you break down that number. So for example, if I split 24 into, let's say, I could do 4 times 6. Now neither of those are prime numbers, so I need to go further. And I can break 4 into 2 times 2, which of course are prime numbers. I could break 6 down into 2 times 3. And all of a sudden I've got 2 times 2 times 2 times 3, which is the exact same answer I got down here by breaking 24 into 2 times 12. So it makes no difference how you split that number up, you will always have the same prime factors at the end of it. So what I want you to do now is to pause the video here and to have a go doing these on your own. Okay, so with the number 12, we've got 2 times 6, 2 being a prime number. And then we split the 6 into 2 times 3, with both the 2 and the 3 also being prime numbers. So 12 is 2 times 2 times 3, or 2 squared times 3. With the number 32, we're going to split that one up into 4 times 8. We're going to split 4 into 2 times 2, both being prime numbers. We're going to split the 8 into 2 times 4. I'm going to split the 4 into 2 times 2. And we can simplify that as 2 to the power 5. For 50, we've got 5 times 10, 5 being a prime number. And 10, we've got 5 times 2. So 2 times 5 times 5, or 2 times 5 squared is 50. 48, we've got 4 times 12. We can split our 4 into 2 times 2, both which are prime numbers. 12 we can split into 3 times 4. 3 obviously being a prime number, and we can split that 4 again into another 2 times 2, which we can simplify as 2 to the power 4 times 3. Okay, pause the video and try these two. Okay then, so we can do 3 times 12. 3 is a prime number, so let's circle it. We can do 2 times 6. 2 is a prime number, so circle it. And to do 6, we can do 2 times 3, which again are both prime numbers. So 36 is 2 times 2 times 3 times 3, or we can simplify it into 2 squared times 3 squared. For 75, we're going to do 25 times 3. 3 is a prime number, so obviously we're going to circle it. And to get 25, we're going to do 5 times 5, which are both prime numbers. So 3 times 5 times 5, or 3 times 5 squared. I want you to try these ones independently, and remember, it doesn't matter how you split them up, you will always get the right answer. Okay, so I'm going to split 28 up into 2 times 14. I always like to divide it by 2 or 3 because straight away that's a prime factor. And I can do 14 as 2 times 7, 7 being a prime number. So 28 is 2 times 2 times 7, or 2 squared times 7. 40, I'm going to split that into 4 times 10, and then split the 4 into 2 times 2. And for 10, I'm going to split that into 2 times 5. Just to show you again, I could split the 40 as 2 times 20. I could do the 20 as 2 times 10. And then the 10 is 2 times 5. You can see I've got the exact same answer. It doesn't matter how I split it up. So 40 is 2 times 2 times 2 times 5, or 2 to the power 3 times 5. 56, I'm going to do 2 and 28. I'm going to do 2 and 14. I'm going to do 2 and 7. And final one, 66. I'm actually going to split this into 6 times 11 because 11 is a prime number. I just think that's quite a nice one to get out of the way. And I can split 6 into 2 times 3, which will give me this as my answer. Okay, some quick fire questions then. So we're looking for the first 5 multiples of 8, the first 6 multiples of 9, 6 and 7, and looking for multiples of 4. So multiplication then, 8, we have 8, 16, 24, 32 and 40. The first 6 multiples of 9 is 9, 18, 27, 36, 45 and 54. The first 6 multiples of 6 are 6, 12, 18, 24, 30 and 36. And the first 6 multiples of our 7 times tables are 7, 14, 21, 28, 35 and 42. Going along our list on the bottom then, 12 is in the 4 times tables, so is 8, 26 isn't but 20 is, 40 is, and 36 is. So I'd like you to pause the video here and have a go expressing these numbers as products of their prime factors. So let's start off with the first one then. 22 we're going to split into 2 times 11, and both 2 and 11 are prime numbers. So 22 is 2 times 11. 23 was a trick one because 23 is already a prime number, so you cannot present 23 as a product of its prime factors because it doesn't have any. We move on to 24. Now we've got a few for 24. This is what I kept saying about how you can express it or you can break it down differently, but you're always going to have the same prime numbers at the end. So in the first one, we're going to do 2 times 12, 2 times 6, and 2 times 3, which is going to obviously give us 2 times 2 times 2 times 3, or 2 cubed times 3. The next example for 24, we've got 2 times 12 again, but then we've split the 12 into 3 times 4 and the 4 into 2 times 2. Same answer, so 2 times 2 times 2 times 3, or 2 cubed times 3. Another example here then, so we're going to split the 24 into 6 times 4, 4 into 2 times 2, and the 6 into 2 times 3. So again, 2 times 2 times 2 times 3, or 2 cubed times 3. And finally, we're going to do 3 times 8. We're going to do 2 times 4 and 2 times 2, which again gives us 2 times 2 times 2 times 3, or 2 cubed times 3. Last one is 25, so we're going to do 5 times 5. Final activity then is to fill this grid in here. If we take the first one as an example, if I do the factors of 60, this is what I'll get. And then I need to think which of those are prime numbers and write them in the box. Which of those are odd numbers and write them in. Which ones are square numbers, and so on and so forth.